All right, I know I'm late to the game, but here are my solutions to the AP Precalculus 2026 FRQ, the four questions. Okay, I did cross-check my solution with one blogger on the internet, and it's quite concerning because I'm assuming that people want to rush to post the solutions to try to get views and all that, but their solutions were totally wrong, actually. When I was cross-checking, I was like, why doesn't it match? I checked my work with the actual calculator for the no calculator portions. I was right. So I'm a big proponent of quality over quantity and speed. Okay? Hopefully you get that philosophy from my channel. But anyway, I am going to go through this kind of quickly. I'm not solving them live or anything, but I'll give you the general thought process through all the problems. Okay, without further ado, let's begin. Okay, so number one, the function shows the graph of the increasing function f on its domain from x from -3 to 3 inclusive. The function g is given by g of x as this natural log guy, okay? Here's the graph of f, here's g, part A, part 1. The function h is defined by h of x as g composed of f, which is equal to g of f of x. Find the value of h of 2 as a decimal approximation or indicate that it is not defined. Show the work that leads to your answer. So we want h of 2, which is g of f of 2. So we got to find f of 2 first. We look at the graph. X value is 2. What is the output value? It's 5. So we want g of 5. And we plug in 5 as x into a calculator. We should get negative 1.614, rounded to 3 decimal places, okay? Part 2 of part A, find all values of x for which f of x is equal to 3, or indicate there are no such values. So this is the y value, the output value of 3. Hopefully you can see the cursor. So what's the x value? It is 1. X equals 1. Okay, that's part A. Part B. Find all values of x as decimal approximations for which g of x is equal to negative 1.5 or indicate there are no such values, okay? So you just need to graph g of x as one of the y's in your calculator and then graph y equals negative 1.5 on like y2, something like that. Y1 is this guy up here, y2 is negative 1.5. Find the point of intersection. I did this in Desmos. So x is equal to 5.483, around 3 decimal places, okay? It says find all values of x. Well, we know that the natural log is a monotonically increasing function, so it will only have that output value once, okay? If you even really zoom out a lot, you'll see that will never cross again. Okay, now part 2, determine the behavior of g as x values decrease and get arbitrarily close to 1. Express your answer using the mathematical notation of a limit. So arbitrarily close to 1 means your limit should be approaching 1 as x approaches 1. Now, what does it say as x values decrease? That means it's a one-sided limit. So as x values decrease, x is getting smaller. If you follow my cursor, which way are we going? We are approaching from the right or the left? From the right. So 1 plus 1 from the right. Okay? We're approaching from values a little bit bigger than 1. That's what the 1 plus means, which is as x value decreases. Okay? And by the way, they did that because there's an asymptote there. So that's why it's not a two-sided limit. It's a one-sided limit. And it approaches negative infinity. Okay. Part C. Is the function f invertible? Yes, it is. Simple enough. Part 2, give a reason for your answer. In part 1, based on properties of the function f, refer to the points on the graph of f in your reasoning. So this is where they're very picky about the explanation. In the first instance of this test, I believe that was in 2024, 2 years back, they had this exact same question on a different function, but it was not invertible. So they don't have the score guidelines for one. They don't have an example of a past problem that shows what is valid to justify your answer for the case where it is invertible. So to be safe, just write as much detail as possible in the time you're allowed. So what are the key points, though? From the previous scoring guidelines, it seems like they want you to first and foremost define that f is a function, so this is first clause, or I don't know my grammar terms, this first half of the sentence, each input value contains only one output value. If you plug in x, you only get one value of y in the domain, okay? That's number one. That's the vertical line test. They don't accept vertical line test or horizontal line test, okay? But that is the vertical line test, the reasoning behind it, okay? And this is the horizontal line test reasoning. Each output value corresponds to only one input value. So each y value, there's only one corresponding x value. And that's what makes f invertible. Or you can even say one-to-one. I don't think they care about saying one-to-one, but it's invertible because, well, number one, each x, there's only one unique y, and each y, there's only one unique x. Those two conditions, okay? I believe that's what they would want to see. All right, number two, a person purchased a car at the end of the year 2019, t equals 0. The car's value decreases over time. At the end of the year 2020, t equals 1, the car was valued at $27.2 thousand. At the end of the year 2025, t equals 6, the car was valued at $14.8 thousand. The value of the car can be modeled by the function v, given by v of t equals a times b to the t, exponential function, where v of t is the value of the car in thousands of dollars at time t, and t is the number of years since the end of 2019. Lots of words. Usually you can skim a lot of that. Okay, part A, use the given data to write two equations that can be used to find the values of for constants A and B in the expression for v of t. I'm trying to read fast. That's why I'm stuttering. Okay. So we have two unknowns, so we need exactly two equations. And they gave us 2 points, not a coincidence. So we just plug in those 2 points to get our two equations. So point number one is t equals 1. The y value is 27.2. Be careful. V is in units of thousands of dollars. So it's 27.2. Just that. It's not 27,200. Okay. That's what one of the bloggers online made that mistake. Okay. It was in a different part though, but same mistake. What was that? So that's point number one. Point number two is t equals 6. The value, output value v is 14.8. So that's right here, okay? The two green. Now, for part two, find the values of a and b as decimal approximations. So you could totally do it by hand and even with the scientific calculator, or just plug them in as two functions. Let b equals x and a equals y. Solve for a or y. So then graph those two functions. Find the point of intersection. Just be careful which one's x, for which xy is which, or which variable xy corresponds to which variable a and b. Okay, so b equals 0.885 and a equals 30.721, around 3 decimal places. And as a quick sanity check to even make sure that you chose the right one, it's a decreasing exponential function, so that means b must be less than 1. I should fix this. Absolute value of b is less than 1. Okay. All right. Because for this, if this is true, then it's an exponential decay. Okay. Part B, use the given data to find the average rate of change of the value of the car in thousands of dollars per year from t equals 1 to t equals 6, especially answer as a decimal approximation. Show the computations that lead to the answer. Average rate of change, that's just the slope between those 2 points. V of 6 minus V of 1 over 6 minus 1. Put it into your calculator, minus 2.48. I don't think they care about units in this, but I put it $1,000 per year. I would care about units as an instructor. Okay, part 2. Use the average rate of change found in B to estimate the value of the car in $1,000 at t equals 3. Show the work that leads to your answer. So I'm not going to go over the details of how to think this through. I did this in a previous video, I'm pretty sure. If not, I'll redo it in a separate video for this year. But the way to do it is you have your starting point at t equals 1. And instead of using the exponential function, you use the linear model. You use the rate of change from the average rate of change that you just found in part 1. So instead of an exponential growth, you have a linear growth, basically. Or in this case, a linear decay, linear decrease. Okay? So how much do we decrease by? Well, that's the change in time. 3 minus 1, which is 2. Okay, so 2 times the average rate of change. which is 22.42. Okay, again, I can explain this in much more detail in another video if you'd like, so leave it in a comment if you're interested in seeing it, because it's important to understand why this is the setup so that you can do it on your own next time. Okay. Part 3, the average rate of change found in part B can be used to determine the secant line for the graph of B on interval t equals 1 to 6. Let A of t represent the estimate of the value of the car in thousands of dollars at time t years using the secant line. For A of 3 found in part B, 2, it can be shown that A of 3 greater than V of 3. In general, A of t greater than V of t for all t, for t between 1 and 6, non-inclusive. Use the secant line in the graph of V to explain why this is true. So this is pretty much in every year. Basically, the function V, because it is concave up, that is the concept. Because it's concave up, the secant line will be always above the function. So A is greater than that. This I can even draw real quick. Okay. Okay, so something that's concave up, or even in our specific case, it's an exponentially decreasing, okay? If I draw the secant line, look, it's always above. Only because the function is concave up. Even if it's concave up and increasing, your secant line, look, is always above, okay? So that's why. Okay, part C, when the value of the car reaches $2,000, the car owner plans to donate it to an auto mechanics school. As a result, the car will immediately lose all its value. Explain how this information can be used to determine a domain limitation for the model V. Okay, so I believe they're just asking for explanation, not the actual domain, but I had to find it as well. Okay, here's the explanation. So the value of the car follows the exponential model, but it says that the car will immediately lose all its value when the value of the car reaches $2,000. So after it reaches $2,000, it's no longer going to follow the exponential model. No longer follows the exponential model. Therefore, the value of t that gives v of t equals 2 will be the upper limit of the domain, non-inclusive. We don't want to include whenever this time is, because it will immediately drop to 0. We want it to be 0, according to the description, okay? So this would be the domain over here if the question requires it. So you would have to graph V with your A and B that you found in the first part, and then graph another line, y equals 2, find the point of intersection, the x value. In this case, it'll be a t value, so then it'll be 22.439. Okay? All right. Halfway through, part C, this is the sinusoidal model. The figure shows a circular water wheel that rotates in a counterclockwise direction at a constant rate and completes 1 revolution in 10 seconds. This is the period, 1 revolution in 10 seconds. At time t equals 0, point W on the edge of the water wheel, point W is here, up here, is at a height of 6 feet directly above the center of the water wheel. The height of point W from the horizontal line through the center of the water wheel periodically decreases and increases as the water wheel moves. The sinusoidal function h models the height of point W from the horizontal line through the center of the water wheel in feet as a function of time t in seconds. A positive value of h indicates W is above the line through the center. A negative value of h indicates W is below the line through the center, okay? Part A, the graph of h and its dashed midline for 2 full cycles is shown. 5 points F, G, J, K, P are labeled on the graph. No scales indicated, no axes are presented. Determine possible coordinates for the 5 points, okay? All right, so I was hinting at 1 revolution in 10 seconds is the period because exactly, we need this. Okay, so at time t equals 0, W is at the maximum height because it's, even by the picture, right? It's at the highest point on this circle, okay? It's at a height of 6. So at F, we know that it's going to be at a Y value, a height, the vertical value, Y, but in this case it's H, is 6. And then is at time t equals 0, okay? And 10 seconds later, it will get back there. So 10 seconds is going to, it will rotate counterclockwise. So it's going to go this way, right? And 10 seconds later, it'll be back at the maximum point over here. So P is 10 as the time coordinate, comma, 6 as the height again, okay? Now, you could probably just guess, even if you don't know, that J must be half the time. So half the time between 0 seconds and 10 seconds, that is 5 seconds, okay? And then, since this is circular, this is a radius of 6 upward, and it'll be 6 down to the min as well, so it'll be -6, because this center is at h equals 0, okay? And then you can probably guess that G and K are at these horizontal points over here, horizontal quote unquote, okay? So they're at a height of 0, and you could probably guess that it happens halfway between F and J and halfway between J and P, okay? Which, if you remember, all these important points, the max, the min, and the mids are all separated by a quarter period, 2.5 seconds. That's another way to do it, okay? Okay. B, so now we just got to model it as h of t equals a sine of b of t plus c plus d, okay? Find values of constants a, b, c, and d, okay? And I believe I did this, there we go. I forgot the minus sign there, okay. So B is related to the period. B is actually the angular frequency, but B is 2 pi over the period, and the period we said was 10. So B is pi over 5, okay? Amplitude is how much it swings up and down from the midline. So maybe let's do midline first. Midline is the middle point, or we can even look at our graph from the previous slide. This is the midline, so it is at 0. And amplitude is how much it goes up or down from the midline, which is 6. So A is 6, D is 0. Phase shift, okay? How do we do phase shift? So sine of t, just sine of t, it starts at which point at t equals 0? It's at k. It would, at t equals 0, it's at the mid, and then as t increases, it moves to the max, okay? So we just need to shift it to k. 0 right now is here at f, but we just need to phase shift it by 7.5, okay? And we want to shift it to the right. So just like a horizontal transformation, the c should be negative because it's t plus something. We want it as t minus something to shift it to the right. So c equals minus 7.5. We'll do it. There's many possible answers for part A and B. Here's the sample one, okay? All right, part C, refer to graph of H in part A. I just pasted it here. The t-coordinate of J is T1. T-coordinate of K is T2. On the interval T1 to T2, which of the following is true about H? J to K, it is clearly negative because the y value is 0 at the midline. So J to K is negative, not including K, because K is 0, okay? Yeah, it's closed interval. Sorry, open interval, not closed interval. It's open because it doesn't include, okay? And it is increasing for sure because it's going from -6 to 0, right? Negative and increasing. And on T1 to T2, describe the concavity of H. Well, it is concave up. This bowl is opening upwards, so concave up. And when it's concave up, the rate of change is increasing. That's by definition. So that answers the other part of the question, okay? All right, let's move on to the fourth question, the algebra question. So we're given g of x is e to 2x, h of x is log base 2 5x. Part 1, solve. G of x is 1 over e to 6 for values of x in the domain of g. So just to, they don't probably check this, but the domain of g, what's the domain of g? The exponential is minus infinity to infinity. Okay, so no restriction. All right, so we just set g of x, which is e to 2x, equals 1 over e to the 6. We can rewrite e to the 6 as a negative exponent, so then the bases of the exponents match, so the exponent values must match as well. 2x is minus 6, x is negative 3 as a result. Okay. Now, the domain of h is the argument of the log. 5x must be greater than 0, which means x is greater than 0, okay? Now, if we solve, h of x is equal to 3. log base 2 of 5x is equal to 3. What do? We can exponentiate both sides by 2, or you could rewrite from log to exponent form. That's what they teach nowadays, but I don't like it like that. You could just exponentiate both sides by 2. So 5x is 2 cubed. 2 cubed is 8, so x is 8 over 5. Satisfies the criteria for the domain. All right, part B, j of x is this exponential times another exponential. K of x is sine 2x, secant x. Part 1, we write j of x and the expression of the form 7 to the expression. So you can just use properties of exponents. It's like if it's x squared times x cubed, what do? We do x to the 2 plus 3, which is x to the 5th. This is the exact same thing. So it'll be x to the 4x plus 1 when you do the addition, okay? And for part 2, we write k of x as an expression in which sine x appears exactly once and no other trig functions are involved. So we just need to use the identity sine 2x is equal to 2 sine x cosine x. And secant, we can, by definition or identity, rewrite it as 1 over cosine x. These two cosines cancel, so we're left with 2 sine x. Pretty simple. We just have to know these two identities, okay? All right. This one, I would probably guess that a lot of mistakes happen here because of this very first step I made over here. Let me read the question first. Before I get ahead of myself, the function m is given by tangent squared 3x. Find all input values of m in the interval 0 to pi over 2 inclusive that yield an output value of 1. So basically, we were solving for m of x is equal to 1, and m of x is our tangent squared 3x. Okay, if we square root both sides, by the way, tangent squared of 3x, I can even write it as tangent of 3x squared, like this. So we could square root both sides of this square and this 1. But when we square root an unknown, what do? We do plus or minus. That's probably a mistake that a lot of students probably made, is my guess, okay? So we need tangent 3x is 1, and also we need tangent 3x is negative 1, okay? So let's solve the left-hand side first. 3x is equal to, well, when is tangent of something equal to 1 is when that something is pi over 4 plus pi k. So we replace that something with 3x. So you might have done a u substitution, something like that in your class. Okay, 3x is pi over 4 plus pi k, divided by 3 on both sides. X is pi over 12 plus pi over 3k, where k is an integer. And we do a similar process over here where tangent of u is negative 1. So u must be minus pi over 4 plus pi k. And our u is 3x. So that's the back substitution right there. Okay. All right, so now we just got to plug in values of k and check for the solutions that lie in 0 and pi over 2, this interval inclusive. So when k equals 0 on this left-hand side, we get x is pi over 12. Simple enough, that's for sure in this interval. When k equals 1, we get pi over 12 plus pi over 3. Well, pi over 3 is the same thing as 4 pi over 12, right? So we get 5 pi over 12. 5 pi over 12, is that in the interval? It is, because 6 pi over 12 would be pi over 2. So it's less than pi over 2. So it's in the interval, okay? And for this right-hand side, we just do k equals 1, which will give us the pi over 4, okay? So we have 3 solutions in this case. And that's the 4 FRQs. All right, hopefully this was helpful if you wanted kind of a quicker overview or review or whatever. If you're interested in me actually going into the details of solving them more slowly and explaining all the steps more in detail, please leave a comment and I'll find some time to do it in the future. All right. Otherwise, if this has helped you in a way, please subscribe to the channel. Hopefully I'll see you in another video as well. Bye.